So, what is momentum? Well, let's get a big cliff here. And let's say this cliff is like 2 kilometers tall, and one guy accidentally trips. So he's falling, and as we can see, he's like probably has a lot of mass if he's like as tall as the cliff. And then another guy also coincidentally fell, and as we can see, he's like not even, I mean, like around half his body. So this guy has less mass, and they're falling at the same velocity. This guy will, the bigger guy will have more momentum because he has a bigger mass. Momentum is defined by the variable p, and p is equal to mass times velocity. And here's something you have to know. There are no derived units. Kilograms times meters per second. So p is just kgm per second. There are no derived units for momentum. So here's a question for you. A car is driving at 10 kilometers per hour, and the car weighs 1,000 kilograms. What is the momentum of the car? And now you must recognize that this speed is in kilometers per hour, so to change this to meters per second, we're just going to divide by 3.6, which will give us 10 over 3.6 meters a second, or you can say 2.777, repeating meters per second, but it's always best to keep exact values. So momentum is equal to mass times the velocity, so momentum will be equal to 1000 multiplied by 10 over 3.6, which is equal to 2777.78. And we have to, I should have typed the question, that's my bad, but 2 significant digits. So let's just 1, 2, 3, 2.8 times 10 to the power of 3. Keep your units kgm per second. That right there is the momentum. So we know that momentum is equal to mass times velocity, and the question tells you what the momentum is, or in other words, what mass times velocity is. So what you do here now is recognize what the question is telling you. It says that the mass is 2/9, so you can just do 2 over 9 mass multiplied by the, it shouldn't say speed, it should say velocity, so that's my bad. But 1/4 its original velocity, so 1/4 v, and this turns into 2mv over 36 simplified, that is 1 over 18 mv, or if you want to write it less ugly, 1 over 18 mv. So just get this number right here, or let me circle it. Get this number right here and divide it by 18. So 1 point will give you 627.77. And the question gives us 3 significant digits, so we just say that the answer for this is going to be 628 kilograms. This is the answer, 628 kilogram meters per second. So what is impulse? Well, impulse is the change in momentum. So a man is running and he weighs about 60 kilograms, and his momentum is changing. And since momentum is a measure of mass and velocity, does that mean that he's losing weight while running? probably long term, but because we know that he isn't actually dropping pound per pound, like per second of running, that means his velocity is changing. So when there's an impulse, that means the momentum has changed. So the object must be moving at a different velocity. We assume mass stays constant unless it is specifically noted that it isn't constant. So impulse, which doesn't have its own variable, it's just change of momentum, is equal to mass change in velocity. And if you remember, change in velocity is simply just final velocity subtract initial velocity. So this is your formula for impulse. So a box of Tic Tacs is sliding along the table at 5 meters per second. Tom slows it down to 1.6 meters per second. Determine the impulse he places on the Tic Tacs. So this is the weight of the Tic Tacs, but it's in grams, so we gotta divide it by 1000 to get the kilograms, which is 0.015 kg. So now we have mass. Now to change in velocity, well, we know that change in velocity is Vf subtract Vi. Change in velocity will be the final velocity here, which is 1.6. Subtract 5.0 is negative 3.4. So now we just do negative 3.4 multiplied by 0.015. And this gives you negative 0.051 kgm per second. And it's two significant figures, so we're fine. Thank you. Let's take a look at our formula. Impulse is changing the velocity of an object. And because velocity is changing, that means that it's accelerating. An acceleration of an object can only occur if there is a force acting on the object. So force must be related to impulse, because if there's a change in velocity, there's an acceleration, and if there's an acceleration, there's a force accelerating. So this formula right here, this was not the original formula for force. Instead, it was F is equal to impulse over change in time. And we know that impulse is mass times change in velocity. And if you look at velocity and time, change in velocity over change in time is acceleration. So F is equal to mass times acceleration. So if impulse is equal to mass times change in velocity, and force is equal to impulse over change in time, then let's isolate impulse. F change in time is equal to impulse, which means that it is equal to this. This is a formula, a pretty good one, because if you have change in time, mass, change in velocity, you can solve for force. If you have force, change in time, change in velocity, you can solve for mass. Okay, so determine the average force of the rifle acting on the bullet. So M, change in velocity, is equal to F, change in time. So we isolate force. Mass, change in velocity over change in time is equal to force. The mass is in 9 grams. 9 grams, when you convert it to kilograms, is 0.009 kg. So 0.009 multiplied by change in velocity. And now for the velocity, it's change in velocity, and the question doesn't state it, but if it's shooting a bullet, that means that the starting velocity, unless otherwise stated, is 0, and the final velocity will be the number right here. So 200 minus 0 is just 200, and then divide all of this by time, and it would be 3.00 times 10 to the power negative 2. and this is equal to 60 newtons. We can just, because 3 sig figs, 60.0 newtons. So because impulse is related to force and time, so if you have like 200 newtons of force and you apply it over 2 seconds, that's equal to like 400 kilogram meters per second for the impulse. But you could also just apply 100 newtons of force for 4 seconds and it'll be the same impulse. So if you apply less force but you increase the time, the impulse is the same. If you apply more force and the time is less, the impulse will be the same. So you can apply a medium force over a medium time interval.